Welcome to Hovercraft Physics and Chemistry. In this video, we will look at three different ways to represent a chemical equation: the molecular equation, the complete ionic equation, and the net ionic equation. What you see on the screen right now is the molecular equation. This is how equations are normally written. Each substance is written as if it's a molecule, a combination of joined atoms. Here we have calcium chloride, sodium carbonate, calcium carbonate, and sodium chloride. Above the equation, I've drawn diagrams that represent each substance in the chemical equation. Because this is the molecular equation, right now the atoms look as if they're joined together in a single unit. If we look closer, however, this is not really what's being represented in this chemical equation. Some of the compounds are aqueous, meaning they're dissolved in water. When an ionic compound is dissolved in water, the ions are separated by water molecules and move independently. So for example, with calcium chloride, the chloride ions would not be closely associated with the calcium ion. In actuality, they would be moving independently from one another. So we could really represent them in any random position. The sodium carbonate is the same. The sodium ions would not be associated with the carbonate polyatomic ion. The carbonate ion, however, does act as its own particle. Polyatomic ions are kind of like molecules with a charge. In this case, carbonate carries a -2 charge. Again, these ions would be moving independently from one another, and we could really show them represented in any sort of random arrangement. Calcium carbonate, however, is solid. That means the calcium ions and the carbonate ions are closely associated. Calcium carbonate is an insoluble compound. In this reaction, it forms a solid precipitate. The last part of the equation is 2NaCl, sodium chloride. It is aqueous, so again, we shouldn't show the atoms as if they're closely associated like they would be in a solid. We can show them in any sort of random arrangement. That leads us to a more accurate way to depict the formula. That leads us to a more accurate way to depict the chemical formula, the complete ionic equation. In the complete ionic equation, aqueous ions are represented separate from one another. This is a more realistic representation of what's really happening. Instead of writing CaCl₂ as if it's a molecule, we separate the calcium ion from the chloride ions. It's written like this. We write 2Cl- instead of Cl2 because the chloride ions are not associated with one another. There are two separate chloride ions in aqueous solution. Similarly, for sodium carbonate, instead of writing Na2, we write 2Na+ because the two sodium ions are not associated with one another. They're separate from each other and the carbonate ion. The carbonate ion is written on its own as well. There's one carbonate ion in the formula unit, separate from the two sodium ions. In the products, calcium carbonate is solid, so we don't write it as separate. We just write it as it's shown above in the molecular equation. For sodium chloride, we will show the sodium ions and chloride ions as separate. Notice we have two sodium ions represented and two chloride ions. The chloride ions are separate from each other and from the sodium ions. So the best way to write that is 2Cl-, aqueous. One thing that you may notice in the complete ionic equation is that some of these ions are aqueous before the reaction happens and after the reaction happens. Consider the two chloride ions that were originally associated with calcium in calcium chloride. They're aqueous and dissociated on the left-hand side of the equation and the right-hand side of the equation. The same is true of the two sodium ions, aqueous on the left-hand side of the equation and aqueous on the right-hand side of the equation. The calcium ions end up being associated with carbonate ions to form the calcium carbonate. This leads us to the last way that we could represent this chemical equation, the net ionic equation. The net ionic equation only includes those ions that end up reacting, forming something new. Because the chloride and sodium ions just stay aqueous, they don't end up forming a solid, we take them out of the equation. One way to think about the net ionic equation is it shows the action. Calcium ions are joining up with carbonate ions to form solid calcium carbonate. The chloride and sodium ions are called spectator ions. They're dissolved in the solution, but nothing really happens to them. So again, we take them out of the equation. The net ionic equation looks like this. We have the calcium ion joining up with the carbonate ion, and they form the solid precipitate, calcium carbonate. Hopefully that helps you see 3 different ways we can represent the equation: the molecular equation, the complete ionic equation, and the net ionic equation. If you have any questions, please post them in the comments below. I would also appreciate it if you would subscribe to my channel. Thanks for watching.